Okay, we are live. Welcome everyone. This is the July 15, 2020 Diagnostics Deep Dive work group meeting. We'll be deciding which topic we'll be talking about first. But before that, anyone has any announcements this week? Okay. So in the issue for this week's meeting, I suggested we could talk about unexpected behavior use case. I'm not sure if others agree this is a good use case to talk about, or if others have any other use cases in mind.
Yeah, I agree. Unexpected behavior is a good one to take up, mostly because it's a largely unattended area. According to my understanding, we may not have a best practice or a set of endorsed tooling at the moment. So definitely looking at that makes sense.
Okay. I started a document so we can collaborate there. I'm gonna share the link and I'm gonna share my screen as well. Can everyone see my screen?
Yeah.
Yeah. Okay, if I can find the chat. Huh. Okay, fine. Okay, so for the other use cases, we started by listing what falls under this. I think it's more called a user journey. So for the other user journeys, we started by listing which use cases fall under it. For example, for performance, we listed use cases as my application is running slower than it should, my application is running fine, but I want to reduce cost. And my application is showing spikes of CPU usage or slowness over time. So we should start doing the same for the unexpected behavior use case user journey, just because that's what drives the tooling and best practices later. So what are some examples of unexpected behavior we can see on Node.js?
Definitely the first class of use case belongs to the category where your result of a computation is bad.
Bad or wrong?
Yeah, right. So this could be manifested in the form of probably a return value from a function which is responsible for the computation, or it could be like manifested as a untallied database at the end of the day when you audit a DB where these numbers are sitting as a result of the computation is not matching.
Mm-hmm.
Yeah, I don't know if a wrong computation can be manifested or discovered meaning discovered by the end user through any other means. These two are something which I know of, I have experienced.
Mm-hmm. Yeah, I think those two are the most common, at least. I can't think of any others right now. If we remember any other, we can add here. But I think those two are the main bad computation examples. Uh, Another unexpected behavior, and this one is kind of exclusive to JavaScript and Node.js, is unexpected unhandled promises, as this can make debugging hard because you lose the continuity of async operations, but at the same time you don't crash the application, so it doesn't fall under the crash user journey. I think here should be the best place to list it.
Is it related to missing callbacks, or it would be a separate one?
It's a separate one. I think both are important.
Okay.
They can have a similar result, which is uncompleted or uncontinuated async operations or async chains, however you prefer. Um, but yeah, they are definitely different use cases because in non-handled rejection means the program is telling the developer that there is there something wrong happened. Like the program knows that something wrong happens, but the developer was not notified, basically.
Yeah.
Um,
Yeah, this is the manifestation is like you have a callback, which is either a completion handler or a event handler, and vital code is supplied, or there are vital elements of the code that is present in the callback, which is critical to the application's behavior, and the log messages or certain outcome, certain behavioral change in the application uh, led to the discovery that the callback was not actually called.
okay, I think when you said missing callbacks, I understood a little bit differently this use case. Um, this one sounds more like uncalled callback. Missing what I was thinking with missing callback was you have a event or a function that expects a callback, but a callback was not given.
Yeah, I agree. This one is basically uncalled callback.
Yeah, I think the uncalled callback can be more problematic than missing callbacks. Depends on the
Yeah.
context. But
Yeah. And callback is also a kind of little bit loosely defined use case because it's not very easy for an end user to come up to that kind of an inference. The statement which you just wrote is basically residing in somewhere halfway of the problem determination effort. It's
mhm.
still okay. I mean, it is still okay to be called out because it's a unique use case by itself. But the only key differentiation here is that unless you have high quality logs in your application, or good quality observability or serviceability capabilities, monitoring, tracing subsystems, uh, this is this is not detected by an end user. This is done by a support
Mhm.
engineer.
Yeah, definitely. I think a lot of the unexpected behavior use cases, use journeys, will be handled with logging, at least as a first. The first tool users will probably use is logging in these cases.
I
Sometimes
agree.
one tool.
Yeah.
How deep into JavaScript specific misused features should we deep dive? For example, should we list unexpected use argument, as in this is not what I thought this would be? Talking about this is weird. Like the this object. I mean, like this. Is this a valid use case for us, or is it too general in the JavaScript scope?
Yeah. This is valid use case in this context.
Also, on the unhandled rejections, maybe this is a sub use case of a more general use case, which is um, misuse of promises. And there we have unhandled rejections, double resolve, um, double reject, resolve after reject, reject after resolve. All those little scenarios that um, can lead to unexpected results, but if they happen, they don't crash the application. Some of them are detectable via node.js APIs. Maybe all of them are. I'm not entirely sure. Should we go through all of them, or should we stick only with unhandled rejections?
Unfortunately, my understanding about different error scenarios with promises are very weak. So I
I'm
don't
gonna
know.
li- I'm gonna list them, and if we decide that not all of them are should be here, we can remove.
Yeah.
I'm also not entirely sure if all of those are invalid um, invalid scenarios or if they are possible. For example, I'm not entirely sure if multiple rejects is possible or if a resolve after rejects is possible. But multiple resolves is possible, and reject after resolve, I'm almost sure is possible. At least one of those two is possible because we have hooks to identify them in Node.js. Any other unexpected behavior use case?
So when we talk about this is not what developer thought it was, uh, can be manifested as an attempt to perform a wrong invocation. For example, the receiver object or the this pointer is wrong, which means if you invoke a function on that object, the function doesn't exist actually. So most probably it throws an exception saying that uh, dot say foo is not a valid property of this the object or whatever. So I'm just wondering, will it ultimately be detected or discovered as an exception, or is there any other way this will come out by which we should treat it here? I'm just thinking loud.
Um,
Michael wants to be promoted.
yeah. So I think a general use case on this is good, which is not the specific undefined function use case, but a more general cryptic error message slash cryptic error stack trace.
Yeah, makes sense.
Because what I usually see is that folks are confused when foo is not is not a function or foo
Yeah,
is undefined when
I
you.
agree.
Yep. Okay. Cryptic. Did I write it? Oh. Yeah, this one could also fall under the crash, I think, but we can probably discuss here as it will not necessarily crash the application. It can be just logged out. The application can continue running. Any other unexpected behavior use case?
Yeah, there are a bunch of a class of issues related to child process. I'm just trying to see how do we abstract into one statement. So the common issues with the child process is one is uh, unexpected exit code or unexpected termination of the child process. The second class of issue is the piping. or the internal plumbing between the parent and the child is not proper, by which the IPC channel is not functioning properly.
Mm-hmm.
Yeah, how do we see it as mostly the parent and child work in a master slave or in a coordinated manner where master would be giving some command to the child executes and get return back the data or the response. So based on the data passed, the success or failure of the child is asserted. Mostly there will be missing data on either side. That's how we see that the IPC channel is either corrupted or there is a missing data.
Mm-hmm.
You paste the link to the doc in the chat.
Yes. I can
Thanks.
trace again,
Thank
just in
you.
case.
Yeah.
So I think it's important to discuss how to identify these issues. I'm thinking if this falls under a more general use case of misuse of APIs, maybe. Are those two issues caused by misuse of APIs, or are they caused by um, external factors?
Uh, I would say both because there are some known issues with respect to the IPC channel with the client, a child process, long-standing issues which are still unresolved. These are not neither termed as limitations nor fixed. So
Mm-hmm.
a type of the issues could be coming through that, and then another set of issues could be misuse of APIs. For example, uh, feeding a FD. I've
Mm-hmm.
seen uh, programmer passing an FD in place of one of the IPC endpoint, whereas the FD itself is not initialized or it's not a valid FD, and expecting the IPC channel to make it valid and work, which is not that is not how the API works. The API either creates the channel by itself if you pass one of the standard verb, or if you pass an FD, the API take it into bona fide confidence that these FDs are pre-created and start writing or processing into that. So that falls into the category which you mentioned as in illegal usage or misuse of the APIs.
Mm-hmm. I think we can have two macro use cases from this. One is misuse of APIs, and the other one is unexpected behaviors caused by external factors.
I was wondering, like, as I was listening and reading some of the things you have there, like unexpected control flow, is that like apparent to these where, you know, we expected the execution to follow a certain path, but for some reason that path isn't followed, and that could be because something went wrong or we used the API wrong, and therefore like we didn't, you know, we expected a callback to happen, but it didn't happen because we didn't do the right thing.
I think it's included in the other use cases. For example, the uh, if the flow is not what we expected, and because of that a callback is not called, it falls under an uncalled callback. Um,
Right. I was just thinking the beginning, like that, all those, that first set, do
mhm.
those all fall under, we end up with an unexpected, I don't know if like control flow is the right, like an unexpected flow of the application, or.
Yeah, as Matthias said, some of the use cases are concrete instances of the abstract use case which you mentioned.
Hmm.
But at the same time, I also recognize that scenario exists independent of these discrete use cases. For example, we can see several issues of that kind in the help repo,
Hmm.
where novice users come and say, I have this code, but it is not, this line of code is not executed, or it's executed after this line, which is not expected, kind of thing. But that class of issues are mostly reported by novice users, and it's a matter of explaining and clarifying. Not sure whether such scenarios would be documented here, or only production issues come in the purview of this.
Are you saying so like that missing callbacks? You're not sure that would be included here potentially?
Missing callbacks, definitely, yes.
Okay.
But unexpected control flow could be interpreted as uh, poor understanding of the user's front with respect to how the code works. So the issues which I have seen in the help repo is mostly required just explaining how the asynchronous programming works, and they are happy with that explanation.
Yeah. Okay. I was like I was thinking like missing callbacks, which you think are in, is just an example of I didn't get the flow that I expected. And I was just thinking along those lines because then that leads me to think like, well, how would you debug those issues, right? And like, say, for example, the misuse of APIs. I'm just wondering, like, how do you debug that? But I kind of understand that if you misuse the API and it doesn't result in the flow that you expected, there can be tools to help you debug, well, what's the actual flow? And then understanding that, you might realize what you did wrong, right?
Yeah.
I added the unexpected application flow to the document. I think today we can just brainstorm those use
Yeah,
cases.
yeah.
Uh,
I was just thinking
and
that
then,
one's actually the
yeah,
parent of some of the others, not that it's even anything different from the ones you've got there. So happy to move on.
Yeah, on that lines, we could also have unexpected sequence. I mean, as a complement of unexpected control flow, unexpected chronology of the code. This mostly happens with timer events like set immediate, set
Right.
timeout, set interval. Customer says that I have set a timeout for 500 milliseconds, but it fired after 5 seconds. All sort of combinations.
Right. Yeah, you're right, because the timing is often just as it may say, okay, I expected these things to happen, but they didn't happen in the right order. I don't know whether that's like, again, like underflow or separate or whatever, but it's definitely in a separate thing that we would want to help. Like there might be a different way to figure out what's going on that front. So it's important as a separate category.
would this be, for example, when there is a misunderstanding of the event loop and how the events are ordered to be fired?
Yeah.
That could be because
Like,
of, yeah, if you don't understand those, that could lead to these kinds of problems.
yeah, one would be that. One would be the very tight expectation about, or real-time expectation on the first event machinery.
Sorry, can you repeat this last part?
Yeah. So the guarantee which the event loop provides for the timer APIs are never backed up by or never based on any real-time specifications. They provide a loosely defined protocols around, set of input versus set of output in a specific order without telling anything about the actual uh, instance of time in which these things can happen, including the set timeout and set interval API. They say if you say set timeout on X millisecond, the function is guaranteed to be called after X millisecond, not exactly upon reaching 500 milliseconds. So the code which are based on hard real-time expectations are likely to fail.
Right. At the same time, if you set something for like a 10-second timeout and it doesn't happen for 20 seconds, that is something where, providing the tools and how you debug that, like how you investigate that, makes sense in this scope, I think.
Yeah, I agree.
Any other use cases?
There are some cases which I believe, I'm not sure whether these are end user use cases or some internal events which are only known to the uh, core developers. For example, unexpected GC, the workload which based on the experience of the user with a specific node.js version uh, was that, I mean, he fine-tuned the workload in such a manner that the GCs are happening at fine-grained intervals. And when he migrated or when he changed the workload to the slightest, then the GC pattern has changed. He treated it as an unexpected behavior. I'm not sure. These are definitely virtual machine specific internal behavioral changes.
I think that fits though under the unexpected chronology flow that you already mentioned, in terms of if for some reason the GC starts interrupting and delaying things that you expect to happen at certain times in your application, then that does, like the fact that the GC happened earlier or later, normally the developer shouldn't really care, and that's an internal thing. But if it interferes and causes a delay to your application, then that does and can result to that unexpected chronology side of things, right?
Yeah, that's right. I mean, these kinds of internal events or internal behavior changes can lead to such program control flow changes as well. But these kinds of internal changes can also manifest as is without causing side effects. For example, a user reporting directly reporting saying that I seen this unexpected frequent GC that's happening, which never happened in the past. And then when we ask, what is the side effect to the application? There is nothing. I just observed through these tools that this is the GC pattern change that is happening.
Because like my take is, if it's not like it, I guess there might be a concern that it is affecting your app and you just don't know. But like in general, I think the contract is the GC can do whatever it wants. And if it's not affecting your app, like the implementer might decide that, hey, I'm going to do it more frequently because that means you won't see long pauses or something, and that should be okay.
Yep.
But I do see your point that, like, it's, you know, if you suddenly see that, you may be concerned. And does it make sense to investigate that to figure out if there's a new problem or you've introduced something, or I don't know. I can see you spending a lot of time without much result on that, right?
Yeah, a new pattern, especially with the cloud native deployments, is that we have tracing and monitoring capability inbuilt into the services, which means you always have the profile data,
right?
Including CPU profile and things like that. So without any reason, you could be actually looking at the profile data and get alarmed by seeing near 100% CPU.
Right.
And we have seen a couple of times people complaining that my CPU is around 100%. Can you please debug? At the end of the day, we debugged and found out that Node.js is performing optimally because it doesn't have locking calls. The only issue is that the end user happened to profile unnecessarily and got into the
Right.
trouble.
Right.
So
I don't know. Does that also, my other wonder is, like, is that covered under our earlier user cases where we have high CPU usage, or, you know, memory issues, memory pressure, that kind of stuff? Like, does
yeah,
it
definitely
fall into
those
that
are,
one?
yeah. I just mentioned it here
Yeah.
to exemplify that how unnecessary tooling around monitoring can cause alarms to the user.
Right. Yeah.
Yeah.
Right.
Still on this topic, there was someone reported a changing behavior on GC behavior on V12 that was actually a bug, was reported to V8 and they fixed it. So changes in GC behavior do not necessarily mean that things are running optimally. And tracking down these issues is kind of overwhelming sometimes.
Right. In that case, they reported it because it negatively affected their app, or just because they noticed it?
Yeah, I don't remember if it led to performance issues or if it led to the application like the garbage collector maybe stopped tracking some objects and it led to out of memory.
Right. I'm just thinking,
Or
like, those two things relate to the other use cases that we have, right?
yes.
We'd basically be saying, oh, you ran out of memory. Okay, look at the GC behavior. Oh, your GC behavior looks different. That's a hint. And then it's, you know, so getting it to it from that perspective makes sense. And I don't know if we need to cover it again in this one.
I agree. I still think the internal behavior change can lead to unexpected behavior for the user. For example, we made some changes to the order that events are fired by the event loop, while it also falls under the chronology flow use case. I think it's more fitted to the changes in internal behavior because the user assumption was correct before, and after they upgraded the Node.js version, those assumptions stopped working. So it's
the cause is different. I just wonder, is, like, are we going to say anything different on how to debug it?
You have an initial information that it changed between V10 and V12. So I think the approach most users will take is comparing those versions, and this leads to a slightly different debugging pattern.
Right. I guess what I could see is like, hey, you get an unexpected ordering of things or flow even. And then it could be, okay, well, the first thing to like underneath that, there's different potential causes. One, which is like, hey, the internal behavior change. So did you change node versions, right? And then other, that's
That
one
makes sense.
cause. The other causes might be the, incorrect assumptions or using the APIs incorrectly, or there's a whole bunch of, these other things that we've listed are all things that can cause that. But I don't know, like, and so you're right, the debugging for like, is different, but it may be that you always want to start with, hey, things aren't going in the order you expected. The first thing is like, is that because you changed node versions? If so, go down this, hey, there were changes in the behavior path to see if you can rule that out first, right?
Mm-hmm.
Whereas if you didn't change anything, like if you didn't change node, then it's down the other path, which is the, like, you have an incorrect assumption in terms of the ordering, or something like the GCs affecting, causing delays, or.
Yep, that makes sense. Yeah, I think at least some of the use cases we are listing here will become part of the questions when diagnosing
Right. Yeah.
the major use cases.
Yeah.
So
Yep.
we're going to need either to filter out or to clean these use cases first before deep diving into them.
Yeah. No. Yeah. So yeah, in that context, as a potential cause to investigate, the internal behavior change does make a lot of sense.
Any other use cases? I'm wondering if leaking resources is a use case that fits here, like system resources in this case, for example, sockets or file descriptors, things that can, if not handled, they can crash the entire application.
I just wonder if that fits in, like didn't we have an application crash use case?
Yes.
So maybe those fit there.
I don't think we covered this one there. And also, I think you can crash other applications if things get bad enough with one of those leaks. For example, if you start leaking file descriptors, you can reach the limit of file descriptors you can allocate for the operating system, and other
Yep.
applications will not be able to do that anymore.
It just, yeah, my first thought is that you're right that we maybe didn't cover it there, but maybe it fits there, like as the right place to be covered.
I'm gonna add in use cases here, and if we decide that this
Yep.
is not the place, we can move somewhere else.
Yeah, no, it's good so we don't forget it.
Any other use cases?
I can't think of any.
Yeah, I think those are the macro ones. They cover a lot of potential failures that users can see, or potential bugs. We have 9 minutes. I don't think we can start deep dive into any of those right now.
We could spend a few minutes just listing out some of the tools that might help in these areas.
I don't think we did that to other user journeys, but I don't see why not. So yeah, let's do it.
I was just thinking, like, you know, tracing comes to mind, right? Like that's something that can help you understand the flow.
Yeah, I think tracing is definitely a good tool. This is more the asynchronous flow, correct?
Yeah, well, that would help you. Well, even the asynchronous and synchronous flow, right? Like, if what you if what you expect doesn't happen, knowing what happened before it and what happens after it can help you understand why, right?
Yes.
I think like event loop metrics can help in terms of I think tracing could actually help with the timing one too, if we have timestamps, but the event loop metrics is another way, right?
Yes. Event metrics can help with timing, maybe.
Yeah.
I'm not entirely sure they help with timing.
I think they would, well, I think they help you if the event loop shows a large backlog, that can help you understand why things aren't happening when you expect them to, right?
Logging.
Yep. I guess logging / tracing, it's like, what's the line between those? I guess maybe I'll take a cut at answering. Like tracing might be something that we built into Node. Logging is maybe similar, but it's what's you built into your application. Does that make any sense as a distinction?
I don't think that's how I see it.
Okay.
Tracing, I see tracing more as a mapping of events or mapping of flow at least. Or for example, everywhere you trace something, you know that it belongs to a certain event
Right.
that started that chain. Whereas logging is tracing. Maybe that's going too far, but tracing would be stateful and logging would be stateless.
The other thing that came to mind, maybe tracing is about flow and logging is more about like things that went wrong or things that have completed, or, you know, I could see tracing be this happened, then this happened, then this happened, without actually having an opinion on whether it was a good thing or a bad thing. And logging is intended to give you more information about this good thing happened or this bad thing happened, I guess, or whatever, something in between, right?
Yeah, I think that makes sense. Also, tracing seems more like seems to carry more context, whereas logging shows more local context usually.
Right. The tracing hopefully is in the context of what happened before or after versus logging is just I'm telling you something at this time. I don't know how it fits into these different ones, but like distributed tracing, like, open telemetry is the distributed case of some of this where you have like multiple components, multiple services.
Yeah, I don't have much context on distributed tracing. I think it's not that different from tracing in spirit. Like it's still about understanding the flow.
Yeah.
And
Some cases it
preserving
is used to
some
get more
context.
info as well, but
Mm-hmm.
I agree. It's like maybe that should just be a sub-bullet under tracing, right? Like that's one of the ways you do tracing.
Yeah, because you can have like tracing across internal Node.js events and also across all your services that are communicating.
Yeah.
So, and you could be using the same tooling, I think. Event tracing probably works for both. Or not.
I think there might be
Not,
some
not
extra
familiar.
tools, but so it's worth mentioning, but probably fits under that category.
Another tooling from DevTools. It's a super powered logging tool, basically.
Yeah, I mean it has support for trace events, right?
Yeah, it has support for a lot of things. Tracing is a really overloaded word.
Yeah, I know, true.
It's used everywhere.
Yeah.
DevTools can be used for so many things. I don't think it's worth listing everything, but like you can add recent versions, you can add log points. Or basically,
Yeah. I mean, but that's almost a category outside of Chrome DevTools, which is just like a debugger.
I kinda agree. Yeah.
Right, and the Chrome DevTools, one of the things it does is gives you the access to the debug API, but it does also then do things like the tracing and.
Yeah, we under the hood, every debugger will be using the Chrome DevTools protocol, but for example, the VS Code debugger
Yeah.
could be used as well.
I guess, yeah, I was thinking when you said Chrome DevTools, I was thinking of the browser implementation, but if you meant the API, then yeah, they'll all use that.
No, I was thinking about the browser, but the API being the same for all of them,
yeah.
I think at least for me, it means that we probably will not see many extra features on other debuggers that we don't already see on Chrome DevTools.
Correct. Okay, well, I think we're at time, but that.
Yes. We don't have any questions on YouTube, so I think that's it.
Thanks.
We continue in 2 weeks.
Sounds good.
We can
Talk to you
start
later.
with the. Yep. Bye-bye.
Thanks. Bye.
Bye.